So the photoresistor, as the name says, it has a resistor in it, so it's kind of like a smart resistor. So as you know, when we add resistance to a circuit, we are decreasing the current or controlling the current in a more specific way. Now, the photoresistor is it is a resistor, it's just a smart resistor. So what the resistor does is when I get light shining on the pads on top here, my resistance of my photoresistor decreases. And when there's no light, my resistance increases. So we basically have a resistor where this value changes depending on how much light there is. And we can use this to determine what type of light we have in our system, and if it's very bright or is it very dark. And then we can look at how the resistance changed, and then we can see how the light changed in the room. The symbol of the photoresistor can be seen here on the top right. So this is the symbol. As you can see, it's got a resistor in the middle with a circle and with some light indication. So what happens in our circuit, as you see we'll build in this tutorial, is we take the point between the two resistors and take that to our A0 of Arduino Uno. So why do we do that? For now, we have to go back to Ohm's law. So if you don't know what Ohm's law is, I would go back to our resistor tutorial where we speak about Ohm's law and explain how to calculate your voltages and currents with respect to your resistance. It's very important for this part of the tutorial. So Ohm's law, just to recap, is my voltage is equal to my current times my resistance. We're going to use this to calculate what happens when my resistance increases and decreases with our photoresistor. So for the circuit, as you'll see later on when we build it, this resistor here is constant. Let's say this resistor is 5 ohms. In the tutorial, it will be 10,000 ohms, but just for calculations, I'll show you guys 5 ohms. Now this photoresistor can increase or decrease depending on the light source. Let's assume when there is no light in your room, it might be 5 ohms as well. So for this, we can calculate the total current of the circuit because we have the voltage and we have the resistance in series. So my voltage is 5 volts. My current we do not know yet. That's what we want to calculate. And then my resistance is 5 plus 5 because it's in series is 10 ohms. And we can calculate the current by changing the subject of the formula, 5 volts divided by 10 ohms. And this is 0.5 amps. So I've got 0.5 amps running through my circuit here. Remember when we did resistance, the voltage of the total circuit is 5 volts, but every resistor can have voltage across it. And how did we do that? We took the current and times it by its resistance using Ohm's law again. So we've got voltage. We've got the current now of 0.5 amps. We've got a resistor of 5 ohms. So the voltage across the photoresistor in this example is 2.5 volts. So you can see the resistance is the same for the resistor. So we'll call that voltage for the photoresistor. Voltage for the resistor will also be 2.5 volts. So you can kind of see already when I'm going to change this resistance here, my voltage will change across my resistors, and it's the voltage we read out across the bottom resistor that goes to Arduino. So in this scenario, my A0 pin will read 2.5 volts. You guys can see where we're going with this. So let's increase the light of a photoresistor and see what happens. So now the light has increased, so these light beams are getting stronger, and as we discussed, the resistance decreases. So let's say, for example, it becomes 2 ohms. Now we can do the same thing again. So what's the current through my whole circuit? Well, I got my 5 volts. The current I do not know yet, and I can times it by my resistors in series, which gives us 7 ohms. Right? Change the subject of the formula. My current equal to my voltage divided by my resistance. So now we can use a calculator because calculating can be quite difficult in fractions. So we go 5 divided by 7 is 0.71. Let's say 0.71. So you see the current actually increased because my resistance decreased. So now I've got 0.71 amps through my circuit. So we know we want to get the voltage across this resistor. The current through my whole circuit stays 0.71 amps. So what is the voltage across this resistor? We've got my volts is my current, 0.71 amps times by my 5 ohms. So my voltage, 0.71 times by 5 is 3.55. So you saw when this value decreased, my current increased, so my voltage over here increased as well. That means we'll read a bigger number out to Arduino Uno to pin A0 when the resistance of my photoresistor decreased. So when I shine light, my resistance decreased, my voltage increases across my constant resistor, and then I can sense a bigger voltage on my Arduino Uno, and then I know I've received more light in the system. So when I turn off the lights, my resistance will increase, my current decreases, so does my voltage, and then I can sense, okay, my Arduino Uno sees less voltage, that means it's dark inside or outside. Guys, I hope we're getting a bit more. I hope this was a nice explanation. As you see, we're going through tutorials. We'll get a bit advanced because you guys are learning the basics so well. So let's move to the next section and we're going to start putting all the stuff together.